Assalamu alaikum. Today we will learn about the remaining two loci in this chapter. One is about the 90-degree angle and other one is about the area of the triangle. Now I will elaborate these two loci with the help of questions. The question number 1 is construct the parallelogram ABCD in which AB is equal to 10 centimeter, AD is equal to 6 centimeter and BAD is equal to 50. Measure and write down the length of BD. I have already drawn the parallelogram, and one thing, keep it in your mind that the adjacent angles of the parallelogram are supplementary. If A angle is 50 degree, then B angle is 130 degree. We will measure and write down the length of BD. Now the part A is construct the locus of the point P which moves so that it is equidistant from A and C. This one is a perpendicular bisector of A and C and which is already drawn. You can see that. Now the B part is draw the locus of the point Q which moves so that the angle BQD is 90 degree. The angle BQD is 90 degree. Now you can see that Q is the variable point and B and D are the fixed points. Now when the variable point is in between the fixed points and angle is of 90 degree, first of all I will recall the concepts of geometrical properties of circle. There was a property that the triangle subtended by the diameter is of 90 degree. Now this one is a circle. This one is the diameter. Triangle subtended by the diameter is of 90 degree. This angle is of 90 degree. AB is the diameter and angle subtended by the diameter is of 90 degree. Now B and D are the fixed points. You can see that. We will draw a circle in which BD is the diameter. Now this one is BD. BD is the diameter. We will find out the midpoint of BD. This one is 7.7 and the half of 7.6 is, we will find out the middle of this one. We can find out the middle with the help of point of intersection of the two diagonals. This one is the middle of BD where the two diagonals intersects. Now with the center at the midpoint of BD, and radius from the midpoint to D or from the midpoint to B, we will draw a circle. Now you can see that we have a circle with BD as the diameter, and when we will draw an angle subtended on the diameter, the angle is of 90 degree. If we will choose any point on this circle, then the angle DQB is of 90 degree. DQB is of 90 degree. Now the A part and B part, we have drawn the two loci. Now the next portion of the question is the position of the point X which lies inside the parallelogram. The point lies inside the parallelogram is such that AX is less than XC. First of all, we will convert this one into an equation. AX is equal to XC. A and C are the fixed points. Now we'll think about the locus. The distance of X from A and C is equal. X is equidistant from A and C. So this one is a perpendicular bisector of AC, which is already drawn. Now we will switch back to inequality. AX is less than equal to XC. We should remain closer to A than to C. So this one is the portion closer to A. This one is the portion closer to A. Now we will remain inside the parallelogram and closer to A. And the next portion of the statement is such that AX is less than XC and BXT is less than equal to 90 degree. Then again we will switch back. We will convert this one into an equation. BXT is 90 degree. X angle X, the variable point, is in between the fixed points and the angle is of 90 degree. So we will draw a circle with BD as the diameter. We have drawn the circle already. Now angle should be less than 90 degree. Now again look at the properties of circle. This point is X. If we will move this point outside the circle, then the angle AXB is smaller than 90 or greater than 90. This angle is less than equal to 90 degree. And if we will remain inside the circle, then the angle is greater than equal to 90 degree. In the question, it is given that BXT is less than 90 degrees. So we should remain outside the circle. We should remain inside the parallelogram, closer to A, and outside the circle. Now the required shaded region is this one. This one is the required shaded region inside the parallelogram, closer to A, and outside the circle. Now I will elaborate this concept with the help of another example. Construct a parallelogram PQRS in which PQ is 9 centimeters, QR is equal to 6 centimeter, and PQR is 115. On the same diagram, construct the parallelogram is drawn. The locus of the point X, which moves so that it's equidistant from PQ and PR. This one is angle bisector of Q. You can see the angle bisector already drawn. The locus of a point Y, which moves so that QYS is equal to 90 degree. Now you can see that the variable point is in between the fixed points. Variable point is in between the fixed points. We will draw a circle with QS as the diameter. So we will have to find out the midpoint of QS. This one is the midpoint of QS. With center midpoint of QS and radius equal to from the midpoint to Q or S. This one is the locus described by this question. Now, if we will remain inside the, if we will be exactly on the circle, then the angle QYS is 90 degree. Now, the two locus we have drawn, the two loci. The position of a point Z is such that it lies inside the parallelogram. Number one is inside the parallelogram. QZ is less than 90. QZ is less than 90. We will remain outside the circle. And Z is nearer to PQ than RQ. This one is the angle bisector. We should remain nearer to PQ. So inside the parallelogram, outside the circle, and nearer to PQ. This one is the required region described by this question. Now, the next locus, which is about the area of the triangle. ABCD is a square already drawn of side 4 centimeters. A variable point P moves inside the square so that PA is less than equal to 4. PA, we will put an equal sign. PA is equal to 4. A point is fixed. We will think about the locus. The distance of P from A is equal to 4. The locus is a circle with center A. Switch back to inequality. We should remain inside the circle. Circle is already drawn. We should remain inside the circle. Now PC is less than equal to PA. We will put an equal sign. C and A are the fixed points. Think about the locus. The distance of P from C and A is equal. So this one is a perpendicular bisector of A and C already drawn. And we will remain close to C. Inside the circle and close to C. Inside the circle and close to C. Now, another locus is given and the area of the triangle ABP is less than equal to 6. Less than equal to 6. Area of triangle ABP, we will put an equal sign. Now fixed points are A and B. We will consider AB is the base of the triangle and we will use the formula for the area. Half into base into height is equal to 6. Half into AB into height is equal to 6. Half into base is 4. AB is equal to 4. H is unknown. H is equal to 3. Now the height of the triangle should be equal to 3 so that the area is 6. We will draw a line parallel to the base AB having height 6. To draw a parallel line, we will draw two arcs with radius 3 and center any 2 points on the line AB. We will join the top of the arcs to draw a parallel line. Now, if the height is exactly 3 and we take any point on this line, on the parallel line, the triangle APB has base 4, height 3, area will be 6. But the area should be less than equal to 6. And if the height is less than 3, then the area will be less than 3. So we should remain below this parallel line so that the height of the triangle is less than 3. We will remain inside the circle towards C, and area should be less than 6. So this one is the required region described by this question. Now another question about the area. Construct a triangle ABC in which AB is equal to 8. Now all the sides are given. We will use compass and ruler to draw the triangle. This one is AB. BC is 7.5. And AC is 6. When 3 sides are given, we will use compass to draw the other 2 sides, and we will remove the unwanted area of the arcs so that the original figure should not be dominated by these arcs. This one is the triangle. This point is C. Now, the locus of the point P on the same side of AB as the point C, that we want to draw a locus on the same side of AB as C. That is, we want to draw the locus on the upper side of AB such that area of APB is equal to area of ACB. Now, you can see that the fixed points are AB. So AB is the base. Area of ACB and APB is same. Base AB is same for both the triangles, and height should be same so that the area is equal. We will draw a line parallel to AB and having the same height as the triangle ABC. Now we want to find out the altitude of C above AB. For this purpose, we will use these 2 triangles. I will set the one triangle parallel to the base and the other one in this way. And when I will move the upper triangle along the base, I will get lines perpendicular to AB. Now you can see that this line is perpendicular to AB and passing through the point C. So this one is the height of the triangle AB. With the help of compass, and radius height of the triangle, I will draw another arc. Now I will join C and the top of the arc to get a line parallel to AB. This one. Now, when point P is on this line, parallel line, then the triangle AB and C, this triangle ABC. This one is the triangle ABC. APB, sorry. This triangle APB. This one. This triangle ABP has the same base and the same height. So the area of APB is equal to the area of ACB. For area of APB equal to ACB, the point P should move on this parallel line. It's all about this chapter. There are 6 loci in this chapter. Number 1, point P is always at a distance of 2 centimeters from a fixed point A. The locus is a circle. The point P is equidistant from 2 points A and B. The locus is a perpendicular bisector. The point P is equidistant from AB and AC. The locus is a angle bisector. The point P is at a distance of 2 centimeter from the line AB. The locus is a parallel line. The third locus is the variable point is in between the fixed points and APB is equal to 90 degree. We will draw a circle with AB as the diameter. All points on the circle APB angle is 90 degree. If we will move outside the circle, angle will be less than 90. If we will remain inside the circle, the angle will be greater than 90 degree. And the third locus is about the area. The key point in the last locus is we will consider the fixed side as a base. That is, in this question, A and B are the fixed points. We will take AB as the base. And we will use the formula half base into height. We will find out the height of the triangle and draw a parallel line, draw a line parallel to the base with the obtained height. In this question, there is no need to find out the area of the triangle because triangle is already given. We will just draw a line parallel to the base and passing through C. We will get the locus at which all points of this locus will have the same area as ABC. Thank you very much.